welcome to Simcast, a podcast brought to you by the Society for Imaging, Informatics, and Medicine. Greetings, Simcasters. At the heart of a SIP's work is connecting various systems to allow information to freely flow in between. But as these information streams grow in size and complexity, the question of how artificial intelligence, specifically machine learning, can be used to harness this data and drive real decision-making. Clinical Data Informatics, or CDI, aims to apply understanding of not only medical imaging, clinical informatics, machine learning systems, and engineering to create robust platforms for these data streams to impact healthcare for not only individuals but also populations. This episode's guests, Terry Sippel-Schmidt and Dr. Raim Geis, talk with our team about their efforts on the CDI initiative, a series of videos released since January of this year, providing introductions to core areas of this discipline. They'll talk a little bit more about how the inception for these videos came about, the process of collaborating with SIM, curating an illustrious group of faculty, and making these resources available to the greater SIM community. We hope you enjoy.
Well, terrific. Thank you very much, Raim and Terry, for being here today. We're going to kick things off with a question to set the table for this discussion. And can you elaborate on clinical data informatics for our listeners unfamiliar with this term? So what does this mean, CDI?
Well, clinical data informatics, or CDI, it's got algorithms from machine learning, systems engineering. But then I think some of the things most interesting to SIM are just the data itself. This really is, the focus is data science, understanding the data and figuring out what questions you can ask for it. And then now there's this excitement because you have ML or machine learning, which is a new way to try to extract information out of those data. But to do that, the data are the basis of the whole thing. So how do you design, build, monitor systems for medical imaging data in a more sophisticated way than we've done in the past? And it's really a team sport. It's more than just people we've had so far, not just the domain experts, but real, data scientists, and making them aware of what medical imaging data are. And SIM's role in all this is just changing at light speed, right? Similar to the whole data science field. But at base, SIM's strength is its focus and expertise on the medical imaging data. And so with CDI, we see that we've got major roles in just understanding these data, how to manage them, what are the standards and the processes, what's going to be the ecosystem to empower machines and humans working together to make decisions out of these data. And then managing decision-making machines and the data that goes into them and the data that comes out of them is a new thing, or at least we need to do it at a much more sophisticated level than we've done it in the past. And I think people then also coming from the, say, ML ops or systems engineering fields, they need to understand the unique aspects of medical images and the data infrastructure that we need to run those sorts of machine learning or new tools when we're doing it in a clinical practice. And then just figuring out how to integrate all this into busy clinical medical imaging practices.
And to that end, as we were walking around the RSNA show floor at 2021, which is only a couple of months ago, it was really interesting to see the different types of companies that were on the RSNA show floor. So first of all, AI and machine learning is everywhere on the RSNA show floor, right? And it was overwhelming, or at least I found it to be overwhelming and confusing. And it was interesting because it seemed like there were two different kinds of AI companies, the real techie AI companies. So Raim, you kind of mentioned the people that have a background in AI, but don't really understand medical imaging and all the nuances of medical imaging. And then there are the other companies who have the expertise in radiology clinical domain, but don't quite understand what's going to hit them when they go to implement AI because it's so intricate and so involved in their clinical practice. So one of the things I thought was really interesting was just walking around the RSNA show floor this year, and how is anybody going to make heads or tails about things out of all the messaging that they're seeing? And that's what we're hoping to do with CDI. We're hoping to put enough into CDI that people can understand the right questions to ask, if nothing else.
So there's a video series out on CDI, and we'll put it in the liner notes so that people can go look at it. You guys talked a bit about identifying the gaps to create the videos, but there's a lot out there. What gaps have you found that needed to be filled by these videos? Like you were talking about, like differences in understanding and this and that. Are there specific areas where you found that people were having knowledge gaps or other things like that? Terry, why don't you go first?
Sure. There's two different kinds of gaps. Reem was mentioning the different types of audiences. And the first gap was you have the people who work in hospitals or radiology administration or IT administration in a radiology department every day. And they're overwhelmed. And they still have a day job. And they're trying to learn AI and how to deploy AI in their environment and make it work. And they have a whole lot to learn about AI. And as Ray was mentioning about all the intricacies of AI, and one AI algorithm does not apply to all. It just doesn't work that way. And so the gap there is, although there's a lot of AI information out on all sorts of different websites, Coursera and all sorts of different places, and it's excellent information on how AI actually works, it tends to be pretty general, and it doesn't tend to be radiology specific. We live in a different world where it's not just cats and dogs, as everybody likes to say. And the other thing, the other gap, is that as these AI companies are looking and eyeing up the medical marketplace and thinking that this would be a great market to get into, the other gap is international standards. And I'm kind of dumbfounded at RSNA by the differences in the adoption of international standards. And what I mean by that is, for example, DICOM structure reporting and DICOM segmentation objects. As an example, the differences in implementation, you can have the best algorithm in the world, but if you are not implementing it correctly into international standards that current PACS systems can use in their workflow today, it's not going to get to the radiologist when they need it. And if that doesn't happen, it may be the best AI algorithm in the world, but it's irrelevant because they're not going to be able to use it. And so those are the kinds of gaps that we've been trying to identify, is how do you put it all together and make it work for radiology imaging in practice?
To follow up on Terry's point, it's true. It's a tricky thing about machine learning. It will make predictions off of data that it's been trained on, and it'll make those predictions surprisingly well. I can build one of these things in my own place and train it on my own data and then give it new things out of my own data. And it's spooky how well it works. And you're like, oh my goodness, this is just going to blow everything away. But then when I try it on even a different machine in my own place, let alone give it to my friend in a different hospital, it might work, but it might not. And it's not uncommon that it doesn't work. And people who are trying to actually put this into production in busy places, with different scanners, it's hard. And a lot of the time it doesn't work. And maybe it just fails. Then you can see right away that it's failing. But other times, maybe when you try it in your own place, it looks like it's an A+ program. And then in actuality, when you just put it out there, it's running as a C minus, and it takes you a month or 6 months to find out that it's actually making a lot of mistakes. That's scary in a high consequences situation like ours. And I think that's one of the things, people are just learning that this is so easy to do as like a little tiny experiment on a desktop, but it's having it ready for prime time is tough. And to Sim's point, again, having ways, I guess I'd leave the AI part sort of separate and go back to the bigger picture of data science. Data science is where you have huge amounts of digital data, which is what we have now. And you're trying to say, okay, what are the questions that we want to ask of those data so that we can have, in our case, better clinical outcomes? And then what tools do you do for that? And, what data do you look at to try to come up with those answers? And it really, so much of it is all about understanding the data. And now we're realizing, oops, there's a whole bunch about even medical image data that we don't understand, let alone when we say that we're going to try to combine the medical image data with other data, whether it's EHR or Internet of Things or genomics or, which would really, there's a lot of information there that we could put together to get these new insights to help patients. But that comes down once again to understanding the data. And that's just a tough thing right now.
I'm curious, I have a follow-up for both of you. Terry had underscored the importance of international standards and compliance with standards. And I guess a few years ago, we started seeing a lot of new vendors showing up at the IHE planning and technical committees where AI vendors that may not have been as familiar with the history of DICOM and HL7. So I'm curious, from your perspective, are you seeing resistance, or maybe not even resistance, but a lack of appreciation of the value of standards from these vendors? Or is it coming from how is this being received when you're preaching the importance of standards?
It is absolutely critical to be able to roll out these AI and machine learning algorithms at any type of scale to support international standards. I would not say that these small AI companies are resistant to standards. Quite to the contrary. I think that a lot of them have figured out that they need standards. I think the issue is that the standards are a bit overwhelming and they're not sure which standards. Adam Flanders has a PowerPoint slide that I would love to be able to insert here about, the light bulbs and all the different sockets for the light bulbs. And I think that's kind of how they feel, because I think that they're not sure which ones to use. Now, there's definitely correct standards, even within DICOM. It becomes not whether or not to use DICOM, it becomes which objects to use, which information object definitions to use. Do you use secondary capture so that any PAC system can display the image, or do you use DICOM segmentation objects so that it becomes interactive and you can change things before you confirm or edit or deny AI results? I think that the rate of adoption for some of these small AI companies is learning some of these standards can be overwhelming. And one of the things that CDI is in the process of doing is rolling out these short videos, which by the way are all public facing. So it's meant to be for anyone and they're free, is the option to explain some of these standards starting at the beginning. If you're not familiar with DICOM structured reporting, which is not reporting, it should really be called DICOM structured results, it's very confusing, or at least I think it is. And so one of the short segments that we have coming up soon is a DICOM SR Basics video. Shortly after that, it will be followed by an IHE AI results, which is based upon DICOM structured reporting, information object definition, and then also a DICOM segmentation object. And so we're trying to create these short 10-minute videos that are publicly facing that these small AI vendors can take a hold of and grab. And is it going to be good enough for them to be able to implement directly from there? No. Does it give them a starting spot? And does it tell them where to start and which ones to use and hopefully guide them in the right direction? We hope so.
Terry mentioned some things that just go back to it's all about the data, and it's a more sophisticated, we need to know more about the data and we need to know more about the standards, like she was saying about the object capture versus something that's in native DICOM that we can potentially use to manipulate. It's just those sorts of things. And also, if the data aren't standardized, any of these new tools where a machine is going to take in the data and make some decision on it based on having been trained by prior data, the new data have to basically look like the prior data. And this is one of the things we're discovering. It has to look like the prior data at a very granular level. And that's not something we've ever, we just haven't had to have that up till now. So it's like, now we need to understand our data in a way that we've never had to even think about before. But, the SIM members, right, at the moment, the current ones, they at least have a head start in understanding about the data. And so we want to boost them so that they realize, now, okay, you've gotten to X, now you're going to, in essence, go to imaging data graduate school, as well as just teach new people who have skills at looking at the data or building machines, make them at least aware of these problems.
Thank you both for that. So we've been talking about the problems that led you to, creating the CDI. Now let's talk about what it is that you created. So if you don't mind telling us a little bit more about the curriculum, broad categories, modules. Is it a collection of topics pertaining to CDI? So let's start with you, Terry.
Thank you. So CDI actually began at a SIM board meeting a couple years ago. And the discussion at the time this was when machine learning was really first coming up. And Raym definitely comes from more of a machine learning and data sciences background than I do. I tend to come from an international standards and implementation and deployment background, which is good because it combines the two of us, gives us a much broader range of information and insights. So when we were drawing diagrams and Venn diagrams on the board, we had two circles. One was people who know AI inside and out, the Kaggle challenge people, we were calling them. And then you have another group of people who implement radiology in practice on a day-to-day basis and live it every day. And how did we make those two come together? And how do we draw an intersection between those two circles on the board and Venn diagrams? And we decided that's what we need, is we need this intersection of people who know both AI inside and out and understand the pixels, as Raym was referring to, as well as you have the people who know radiology and radiology practice inside and out. How do we develop that intersection? Because that's what we need to deploy AI in a meaningful way in different departments and make it work and make it useful. And that's a whole other discussion about KPIs, but we'll get there. So we came up with several different target audiences. The first was the people who know AI and need to learn radiology. And so we have a separate track in CDI of the publicly facing videos, which are all about on ballpark of 8 to 10 minutes long, called Clinical Practice, where we're trying to explain to the people who know AI but don't know radiology, what does it take to be a radiologist? What does an average radiologist day look like? What kind of problems and issues do they run into? So that's one track, is for the people who know AI but do not know radiology. The second track is for the people who live radiology every day and need to learn AI, but they don't want to develop AI algorithms. They don't want to manipulate machine learning algorithms. They may not even want to label data, although they're probably going to have to figure out how to participate in that somehow at some point for their particular institution. But that's the second track. The second target audience is people who know clinical practice and are going to have to deploy this stuff, but they need to learn something about AI, specifically how it applies to radiology. And then the third track that we have, and potentially we'll have a fourth track in the not too distant future, but the third track is learning more about AI and data science. And that's the more technical track of the people who know radiology, but really need to, as Raym said, understand the AI algorithms at the pixel level. and understand why this particular algorithm doesn't work on this particular scanner, which, by the way, we've run into already. And as Ray mentioned earlier, some AI algorithms will look great, A+ algorithms, I believe you called them, but you implement them locally on your particular systems and suddenly they're a C- algorithm. And those are the kinds of things looking at the pixel level data that the third track is for.
Yeah, when we started this, Terry was really focused on the data and I was still at that naive enough. I was excited about the algorithms, right? And now, with just the problems that we run into day after day after day about making algorithms, it's not that they don't work, it's that they don't generalize. And why don't they generalize? It's almost always because of something about the data. And so I always knew Terry was like really, really smart, but now I'm figuring out just how smart she is to be focused on the data. And I've really come over to her side more, that's the foundation of data science, is that you've got data that you can actually work with. And trying to understand our data as it is now, again, at a granular level, and understanding just how to look at the data. How do we describe it at a pixel level? Not, oh, this is a brain CT, but, oh, these are the subtle pixel variations that come with, brand company X's CT scanner version, whatever, with this software and a certain tube. All of that changes the data at a granular level. And we got to figure out, there's just a lot of basic research even that has to get done. What of those parts are important? How do we describe them? How do we look as the data are coming into our machine learning algorithm or whatever the machine's doing? How do we look at those data so we can say, oh, these data are going to work, or, oh, here's some data coming in and they have different features and they may not work, or we need to at least watch more carefully how they're working. And then monitoring the data that's coming out of these things. Again, it's understanding the data is the absolute foundation of data science. And so we need people who understand the medical image data in a way that hasn't occurred to us until now, that we need to understand it at that level.
And just a quick follow-up on what Reem just mentioned there. One of the discussions that we've had extensively is monitoring of all these systems, and call it ML DevOps, call it AI monitoring. There's a lot of different words floating around out there. But how do we know when one of the algorithms seems to be working in your department? And, who knows, maybe a CT tube was changed, maybe just the software was upgraded, which happens fairly regularly. And suddenly the AI algorithm went off the rails. Or worse yet, it didn't suddenly go off the rails. Worse yet, it over time just kind of degraded and slowly went off the rails. And so it's harder to monitor and harder to identify. And those are the kinds of discussions and issues that we hope that this series will bring up to people who are working in practice today.
Yeah, it's really crazy to think from the visual point of view, right? You change out the tube, the images look pretty much the same, plain films, CT, whatever, right? But you're absolutely right. From the data point of view, the data has to change because, one of the variables in the data creation has changed. Whether it's 10% higher energy on the KV or there's just a slight bit of variance in the MA from the actual generation of the electrons to create the X-rays, right? So from our eyes, it looks about the same. And, we're not going to do anything, but the computers are definitely going to be able to pick up on that variance. And it's going to make a huge difference for these algorithms. And yeah, this makes for a very, very difficult problem despite all the AI hype that's out there. But I'd like to pivot a little bit and find out a little bit about how you recruited the CDI faculty. Did you dig up dirt on people and blackmail them into it, or you provide them muffin baskets or something? Like, where'd you find the people to do this? And were they all excited to get involved?
Carrie is very persuasive.
There was some begging.
Well, just, as an aside, it's hard right at the moment. Got the plague. Everybody's working hard. Just into everybody's individual jobs are more complicated now because of COVID. And, I think we're seeing certainly I know among physicians, even the academic physicians are being asked to just do a ton more clinical work. So there's a lot less time for volunteering. We've still been able to get people because they're excited about this, but we owe the people who are making these videos a lot because it's a sacrifice. I think one of the reasons that people are excited to do these videos is because they're realizing that this is so important. AI in medical imaging isn't going to happen anytime soon if we don't get these issues about the data solved. It's just not going to work. But at the same time, there's so much value that we can see that if we get the data right, we can learn a lot about how to take care of patients or predict disease or improve population health, because there's information in these data that can help us understand disease and people. But we got to do it right. And to do it right, we have to understand the data. And I think people now, we had this little hype where we all built the algorithms, right, in our own place. And it's kind of like building, a lawnmower engine, and I build it and it works and I can do cool things. And it's just spooky how well it worked. But now I'm realizing that I can't take my little lawnmower engine and stick it in my car and drive it down the highway. It's like, oh, wait, I got to learn a lot of new things before I can do that. But I can see already that once we learn how to do that stuff, it's going to be really cool and very helpful to patients.
So one of the things in terms of recruiting that both Reem and I were pretty adamant about is we have kind of two different groups that we're recruiting from. One is the experts. And to Reem's point, they're very interested. But I think that they're also, I don't want to say scared, but in some ways I am going to say scared and a little bit afraid because it's become apparent of the things that can go wrong, especially if you rely too much on AI. There's been plenty of papers published about, look what a great job this AI algorithm is doing detecting pneumonia. Oh, really it's detecting the L on the radiograph because that way most of the people were in ICU. So those papers have started to be published. And so I think part of the reason that people will take the time out of their incredibly busy day to do some of these CDI videos for the experts is that they understand how much can go wrong. The other thing that we've been trying to do, though, is we've been trying to pull in a group of people who aren't the experts and who aren't the people who do the talk circuit and who aren't the people who are the people that you're going to see, speaking at RSNA and SIM. They're usually younger. They're usually perhaps SIM members in training. And they're the ones who are going to have to live with AI in the next generation, 10 and 20 years from now. And they're going to be running the radiology departments in 10 and 20 years from now. And so we've been actively trying to pull those kinds of people in because we feel that it will really help going forward.
Yeah, I think that's a group that's just really promising. We're seeing, at least at the professional level, physicians, whether they're radiologists or pathologists or dermatologists, the young ones who have, really pretty solid computer science chops. Oftentimes they get it. They come with different skills. They actually still don't have necessarily the radiology informatics skills, but hopefully if, as they spend more time at SIM and just deal with the radiology data, they'll get better. I think the same in terms of IIPs, that you're starting to see some people who, again, have computer science or ML ops kind of interest. Like I've given some talks at engineering departments, and, I gave one at MIT, and afterwards, all these young, super bright kids came up and were like, wow, I had no idea that there was all this opportunity there. And really, at the moment, it's white space. There's a lot that just hasn't even been embedded. So we're trying to pull those people in right now.
So I want to ask a behind the scenes question, if you don't mind. Obviously, we talked about how you found faculty and defined topics and whatnot. And obviously, behind the scenes, it's not just that you find people are like, yeah, go make videos and boom, it's done. Obviously, there's more work. So can you take us through what it was like to get these videos prepared, how long it took, and all the barriers that maybe you bumped into in the process? Let's start with you, Terry.
Yeah, it took way longer than I ever thought possible. The hardest part of any project is getting started, right? And this is no different. The hardest part of getting CDI off the ground was figuring out what we were actually trying to do and crystallizing it a little bit more. It started as a brainstorming session in a sim board meeting a couple of years ago. But then when you go to put things onto paper and say, here's our list, it evolved and evolved and evolved. And that's a good thing, because I think as we learned more, I think that it needed to evolve, especially in such a rapidly changing field. How long did it take? I'm not sure I want to admit to how long that it took. Over a year, it might even be over 2 years at this point. But we now have maybe 6, 7, 8 videos that are rolled out, and they're coming out about once every week, once every 2 weeks. And we want to continue that. The hardest videos were the first couple and trying to figure out what our target audiences were and our target tracks. I think that we have that figured out now, although truthfully, it's got to continue to evolve. And I think that that's something that we're willing to do as we go forward.
Yeah, everything's changing so quick. We started with these, what we thought were up-to-date ideas about how to do this. And then just sort of the ground would shift under our feet. And especially, I think, as we started realizing and more people started realizing just how hard this is, and just everybody sort of gave lip service to, oh yeah, it's all about the data. But now it's like, oh, well, if we don't get the data right, this stuff isn't going to work. So, and what the problems are.
And as a follow-up to that, Reem, to continuing to evolve, we need to continue to hear from people, right? I mean, we need people to go watch the videos that are out there, tell us what they think about those videos, because if they're off target, we'd like to know that. Tell us what gaps they see, what other videos they would like to see, because it's really our job is to serve the people who are looking for this type of information. And so the more feedback that we get back on the content that exists currently, as well as the content that they feel is still missing, I think the better off the CDI series will be, right?
Absolutely. And I think, deviating a little bit away from your question, but one of the things that we're seeing in terms of this rapid evolution is what we call multimodal machine learning, where you're not just looking at the medical image data itself, say a CT scanner, but you're trying to combine that with other data that are available, whether that's from the EHR, the genomics, or the pathology, or just other things that are known about you from the internet. That's starting to interest people, and at a institutional level, that's starting to gain a fair amount of ground. So now I think we're still trying to figure that part out. Is that, are the people that are going to do clinical data informatics, as we put it, are we going to try to say, oh, these are going to be the experts on the medical imaging part, and then they're going to, inside, say, a big hospital institution, that they're going to work with other people that are dealing with the non-imaging data? How do you communicate with those? What roles do our people have? Again, these are huge, complicated issues. we're not going to solve them necessarily, but at least start to give people the tools to be able to feel their way around in a new setting.
What can our listeners expect for future topics? And I think Terry kind of alluded a little bit to this earlier that, you want feedback for where you're at and where you might go. But what do you guys have on the docket?
We have a list. We really do have a list. And let me give you some specific examples. There's our list of things that we would like to elucidate more on standards. For example, there's Firecast and the ability to take the confirmed information out of the AI images and put it directly into a radiology report. That's critical in terms of time savings, which is a huge key performance indicator, a KPI for AI, right? If time savings at various steps in the radiology practice needs to be one of the KPIs to justify deployment of AI in a practice. So we have one on Firecast. We have one coming up, we call it DICOM Part 2, which there's already a DICOM, just a 10-minute introduction to DICOM for the AI KO crowd out there. But the next DICOM Part 2 is much more detailed and much more specific and talks a lot more about, data types and gets into the gory details a bit more. There's one, as I mentioned earlier, coming out on DICOM structured reporting, one coming out on IHE AI results and getting into the technical details so that a small AI company can actually begin to implement AI results, which is based upon DICOM structured reporting. There's one coming up on DICOM segmentation objects and why it's so important. So that's kind of the technical track. Actually, another one in the technical track that's really important is IHE SOL, which stands for Standardized Operational Log of Events. And if you don't have all of these different systems implementing IHE SOL, how are you going to be able to even evaluate your KPIs and figure out what's working and what's not? And so that's another video track that's coming up soon. And those are all in the kind of the technical category. There's other tracks that are coming up, and there's some fantastic. There's a couple of really, really good videos out there already about how to make AI work within a practice and the different kinds of AI, whether it's, segmentation or classification. There's a couple of really good videos on this website already about those. Another example, though, is one of the videos that came out recently talked about why AI labels are important and how you do them and what they are. But we need something about how do you actually implement that? And so one of the tracks that we're trying to really work on is like the deployment in a particular institution. As Reem has mentioned a couple times already, just because you've got this wonderful AI algorithm, when you put it into your institution, it doesn't work as well, perhaps, possibly. And so we need ways to help people figure those things out. And so those are the kinds of tracks that we want to have going forward. And we really do have a list of both tracks and really, really good presenters.
Yeah, and I think some of the other things that we're looking at are talking about what are clinically actionable data and just what data are out there from a clinical standpoint. There's both the medical image data and then what are other things that, say, somebody who was trying to keep track of the data would want to know about or make them aware of, here are genomic data and, they've got their own rules. And even just recently we discovered, for example, that pathology data and like the FDA rules for clearing pathology algorithms are entirely different than the FDA criteria for clearing radiology algorithms. And so, just because somebody learned to do or thinks they understand, something doing in pathology, at least at the moment, you got to do it in an entirely different way for radiology. Maybe that's a different thing. Now we need to go and have a set of talks for the FDA. But just there's a ton of gotchas here and just trying to make people aware of these things in terms of the building blocks. But again, I guess I'd go back to it. Terry's been sort of saying this, but I'll say it more bluntly. It's all about the data now. It's like the algorithms are almost ephemeral, really. They're the sexy part. They're what everybody wants to work on. But this stuff is not going to work in our institutions and take care of our patients until we get the data right. And to that point, SIM is like this golden place. It's the only society where people have an interest in medical imaging data, both interest and experience. SIM is just critical. If we don't get this data stuff right, we're just going to really have a tough problem here. So it's both a huge challenge, but a huge opportunity for SIM and SIM members and new people who want to get involved in this field to be there. So we're kind of chipping away at it, but we're also very optimistic. We're excited. I mean, the people at SIM are asking the real questions that matter right at the moment.
Do either of you see this as a potential certificate program in the future?
Yeah, I mean, of some sort. I mean, there's going to be a need and value to demonstrate that you can do sophisticated data management of medical imaging data, as well as doing, the ML ops, which is trying to figure out how do you bring the algorithms, bring things online, how do you develop the tools, and then, what you call SREs or systems engineering, where you're going to have to be able to monitor this stuff. Those are highly technical, very skilled jobs. They're going to take a lot of training, a lot of experience. And I think anytime you have something like that, having a certificate to demonstrate that you can actually do that will help institutions understand if you have the skills to do these things. But having said all that, I can see that that's off in the future somewhere. We don't even know what we're supposed to teach people to do. We're still sort of in the prototype research phase of figuring out what do you need to understand about medical data and how do you monitor these things? And how are you going to bring a machine learning algorithm online and know that it works? And what happens if it's not working and you have to take it offline? How does that change your whole workflow? I mean, the issues are many.
So I don't see CDI itself, this particular project, becoming a certificate program. CDI is intended to be an externally facing introductory short series of videos to introduce different target audiences to different issues and to kind of guide people and tell people where to go. I could see, for example, the SIP, help me out here, Raim, SIP stands for Certified Imaging Informatics Program.
Professional,
darn, I was so close. I can see the SIP program having perhaps an additional certification, or SIM having a certification, which is kind of above and beyond CDI. CDI is really meant to be helpful introductory short videos, which then draw people into SIM further for the more technical and detailed, even at like the annual meeting, where we get much more in depth. So I don't see this particular CDI as being certifiable, certificatable. I'm not sure what the word is there. But I also expect that some of the universities will start to have projects or programs in this particular area, but that's even further out.
Yeah, to go back to what Terry's saying. Yeah, CDI itself, I think one of the things, again, we started talking about this, clinical data informatics is a team sport. We need both to train the people that are already in imaging informatics to boost them up to understand the new stuff. This stuff takes a lot of skills from a lot of other people. It really is a team sport. So one of our goals is to, we just have to attract people from the classic technical fields. And it's not just computer science, it's systems engineering, it's data science and statistics that, that come to us with, really high level skills in those areas, because we need those people to make this ecosystem work. And that's our goal with CDI, is to try to create a greater community of people, again, interested in clinical data informatics.
Thank you both for that. It's been a great episode, very insightful. And with this, we're actually getting to the end of the episode. So I would like to ask both of you for any final thoughts, closing remarks. Raim, would you like to go first?
Well, this is a really exciting time right now, and SIM is uniquely positioned to play a major role in this. And we look forward to trying to involve a lot of new people, particularly young folks who are traditionally associated with SIM and also outside of SIM. This is it's a fun field. It's got a lot of value for people, and it's going to help patients a lot. It's just so exciting right now, and we're glad to be part of it.
I completely concur with everything Raim just said, but I have a little short story for you. So at RSNA, I cannot count the number of people who walked into the booth last November, only 3 months ago, and said, yeah, so I was told by my president or my hospital board or board of directors that we had to implement AI. No one really knows what that means, but I'm here to learn. And we need to implement AI in our radiology department. And for those people who also have day jobs in addition to just going to implement AI for their department, CDI is a great place to start. And I would say not only start with CDI, the videos, just to get some context in place, but start looking at small projects. And as Rain mentioned, start developing your cross-functional team around your projects, or probably develop your projects around your cross-functional team. There's a great paper in JDI, in the SIM Journal of Diagnostic Imaging, by Krishna Jularu, that talks about taking a very small problem and implementing it so that it's something that's attainable. And I thought it was fascinating how it was kind of like an experiment almost at Memorial Sloan Kettering, and all the issues and all the things that they learned. And when I read the paper, all I could think was that it was such a great way to get started, was to start small and really begin to understand and run into all these issues themselves. And I would take that a step further and say, if you are going down that path and there's certain videos that you, or certain topics that you would like to investigate further, please let us know, because as we mentioned earlier, we're certainly looking for feedback.
Wonderful. Thank you so much. It's been, again, a very insightful episode. Appreciate your time, and hopefully we'll get to catch you soon.
Simcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.